Opposite Gloves here, and this is a video that's just going to display the basic filter types. So let's get right to it. So I have a harmless loaded up here, and I chose harmless because I have a whole friggin' series on harmless. So if you don't know about harmless, you can go watch that and you can learn all about how to use it. I even have a few demonstrations of songs being made with pretty much only harmless and some post and drums. So let's get to the filters. So what a filter is, I'm going to use an EQ to visually show you what a filter looks like. But a filter, what it does is it selects a frequency and it turns that frequency down. And it can select a whole group of frequencies, and as you select your frequency via like a knob of some kind, which right here we have a filter section, it will reduce the volume there. Now the difference between an EQ and a frequency filter, or just a filter, is that an EQ generally only goes down to, like, this one actually goes pretty far, negative 18 decibels. And it's to shape your spectral content to make room for other things, versus a filter. Filters can go down only a little bit, and there's all sorts of crazy shapes, and we'll talk about that as soon as we get through our basics. But they can also go down to negative infinity, so it reduces the volume forever. And of course, these things are not strictly true for all filters, because there are different sorts of equations and things that can make it very different. And especially with the way digital is going right now, it's very likely that most parametric EQs, or most EQs, will now serve the function as a filter if you so desire. But in the old days with analog equipment, that was pretty much true. That was the difference, big difference between filters and EQs. And as you can see, if we click our different types of filters, we have low pass, 2 band passes, and then we have more low passes and band passes. We have like 5 low passes in total here. And so what the heck is the deal with all these different shapes and things? Well, let's play our sound. And right now we have a saw wave with the fundamental and the overtones. That's covered in actually the first few videos of the Harmless series, if you don't understand that. But let's talk about the basic filter shapes now. So by reducing spectral content, so here we have our sound, and it starts here and it goes up to here, and we could say this is our low, mids, and highs. And by reducing the volume in certain areas, we are filtering it out. Okay, and so the first type of filter is called a, we're going to do, let's just start from the top, a low pass filter. And so right now, nothing's going through, and we've selected our frequency. Like right here, if we were to change it, if this were to represent where that knob is, this is at 20,000 hertz. So that's the top end of our hearing range. So we don't hear it being affected. But as we move it down, we select a lower frequency. It turns off the volume of the frequencies it's passed over. And as a result, so right now we have it selected at 233 hertz. Everything above that is being applied according to the curve we've set. So some curves are much harder than others, so they turn off the volumes faster when you move. And in the parametric EQ, you can actually go to order, and you can select a different type of order, and it will apply a different type of curve there. So that's one reason why there's 100 million different types of filters. It could be just the curve, and that could make a big difference how fast the volumes turn on and off, whether or not it can even turn off the volume all the way. And that's that. Now there's something else you can do. You can add resonance, and that's a boost wherever the cutoff frequency is. Usually nowadays you can actually select where you want your resonance individual of where your filter is. It's crazy. But if we scroll up with the mouse wheel, you can see we have a curve boosting the volume right here. I didn't make this clear yet. This is your spectrum. X-axis is your spectrum. So your hertz values, frequencies line up here according to what frequency they are. And then the up and down, the up, so this middle line is 0 decibels, and up is 18 decibels, is down is negative 18 decibels. I'll probably have a separate video talking about decibels and the idea behind them, because they're weird. They're not, when people equate it to volume, it's not true. Like, it's a good way of thinking about it, but if you're going to get technical with it and sort of understand what you're doing, you need to understand sort of the psychology behind decibels in the math. So we have our resonance here. And that's a really common sound. Like, that's the sound that most people are familiar with, especially in like 80s gear. So That's what that is. So this is a low pass filter. So when you see one, that's what that is. Then you have a bandpass. So what a bandpass is you create a band, and only the frequencies in the band are allowed in. So those are the only ones you hear. And if you can scroll up and down and change the band width. And so on here you actually see on Harmless it's called width, but in math equations and other things, bands are usually referred to as Q, and the size of Q. And so if you ever see Q, that's what they're referring to. And yeah, by dynamically changing your bandwidth and where your band is, maybe you have a really big band, maybe a not so big band, you will get your sound. If you watch my making a drop with Harmless, part of the way through the video, I actually switch for my major drop sound to a very large band, and I add resonance in weird places by combining a bunch of basic filter types, and I actually use the EQ2 to do it. So that might be of interest to you. But that's what a bandpass is. So whenever you see that, that could be very important, especially like I didn't know what it did at first. So I was just selecting crap to see what it did, and I was just blown away. I was like, what the heck is this thing doing to my sound? And now I know. This one's called the high pass, and it's the exact opposite of the low pass. It cuts off the low frequencies first and goes up to the high frequencies. And it can also have resonance, like so. And that's probably a sound you're very familiar with. But that's what the high pass is. Then you have a band stop. This creates a hole in your sound. Now with this one, you cannot have resonance, but you still have Q. You still have a sort of a band, so to speak. It's a hole now, and you're controlling where that hole is. And in this synthesizer, it's actually got a phaser setting. This technically a phaser takes your sound and inverts the signal, and it phase cancels out that part of your sound. But with this is actually a filter. So this is a band stop filter, and as you move it around, it creates a hole in your spectrum. And usually there's like 2 or 3 of these things. So if we add another one, and they move around in tandem. But with the filter option, they could stay still because it's a frequency, so it moves. But let's go to, where is it, band stop. And you can have 2 of these guys. And they create interesting holes in your sound. And there's a whole bunch of different ways to do this and sizes and things, but that's what a band stop filter is. And then you have a low shelf. Oh, well, these aren't filter types, so we're not going to talk about these because these will just confuse you. These are for EQ kind of adjustments. So we could take, let's say we have some other filters going on at the same time. You can create some really dynamically changing options here. So let's say our main filter, we're going to change all these to one type so that it's not so confusing. Okay, so with an EQ, you can simulate resonance only in specific areas of the band. So we could take this is actually called peaking. I guess we will have to cover this. Peaking is where you just, you select an area you want to cut or boost, and you can do that. That's an EQ thing. And you can also do a low shelf and a high shelf. A low shelf, I guess I didn't plan on covering this, but whatever. A low shelf boosts like all the low end from wherever you select, and you can change the width of that as well and the steepness. And a high shelf does the exact opposite. And now most EQs, pretty much every other type of EQ, has some limited form of any part of these options. So some EQs may just be a low shelf and a high shelf. And that's the only options you have. Other EQs like this one are very specific. You can get really detailed in how you want your volume of your content to come out. So we could have a low pass filter here, and we say, okay, that's what we want right here. And we could even add resonance right here. So we want our high end to be emphasized. We could make this middle one a band stop filter, and we can make it like kind of small because for whatever reason there's a frequency here that's pissing us off. If we're making our own custom shape, and we can make this one right here a high pass filter, and we could do that. Maybe we don't want our low end. And then we can make this guy right here maybe just a ridiculously huge band pass filter. And then you could choose to automate any one of these to create these dynamic sounds, because you can move the resonance around and you just get all these crazy sounds. So let's really quick just do that. let's put down some notes. I'm gonna make them low notes, or you know what? Let's make them chords. That way we have a large spectrum. As you can see, our filter is taking effect. Now, as I said, this is technically an EQ, but these filter shapes are combinations of those shapes. So you have your basic ones, and I believe Crude has a much steeper curve than Classic. And I believe Classic introduces some resonance. I'm not totally sure. I haven't like looked in detail at these things, but I know generally what I'm doing when I see like band pass, band stop, high pass, that type of thing. When I see these special ones down here, they're just different kinds of those. And maybe they're a combination of filters where there's a leaky low pass makes me think, oh, the low pass has maybe a second filter moving in it that behaves differently. But let's go to our EQ and let's automate 4. To automate these positions, we're going to automate 4 first. So we'll create an automation clip. Automate 5 next. Create an automation clip. We'll automate 2. And if you don't know how to do this, I have a How to Make Your First Song in FL Studios that answers how to do this. And so we have our automation clips here. And so we're going to move 4 around first and see what that does to our sound. And 4 is the low pass. I'm going to make this stay on the screen so we can see it all the time. So here's 4. And so that's what happens when you move 4 around. But we could say, oh, well, now hold down Alt on the right side of your keyboard and click to mute it so it'll stay put. Let's move around 2. See what that does. Or 5. As you can see, we got that sort of movement. If we combine them and unmute it. We get a bunch of interesting movement. We can now start to move around. I believe this one is too. So we're moving around the stop now. So we'll probably get some more holes in our sound. And now the lower end is the lower end of our spectrum. The upper end is the upper end. So this is going to hit, when it comes up around here, it's going to hit around this area. And then we can move, finally, we can move around our high pass. Now we want to be careful with our high pass because we know this is going to just, oh no, is this a band pass? I cannot remember. No, it's a high pass. So this is going to jank our frequencies, man. If we put it all the way up here, there isn't going to be nothing. So we want to be careful about moving this guy around, maybe only up for like a moment and then down and maybe come up and down. Not like huge movements unless you like want to deliberately do that. As you can see, there isn't nothing. So let's do this. And you could change the behavior of each one. So that's a way to create some interesting movement, and that's how you combine a bunch of basic filters. Well, alternatively, we could just use one and just get the classic sound. For example, if we just get rid of all of them except 5, and we change 5 to a high pass. And let's make a much, like a real high pass. Let's make it a steep 8. And so that's how you get those different sounds. And now you have an idea of what they're doing and how to make custom sounds and all sorts of interesting things. So when you look at filters, it's not a total mess to you. Now, something they do with, when you have 4 things going on like this, it's a custom filter, but you've only got one knob to control it. Maybe you got this width knob here. It may limit you in your options as far as creating something as complicated as we just did. But also, they usually have it linked up so that all 4 move when you move this one knob. Like it selects frequency for all of them, but maybe it has like a math equation that says for whatever value 5 is, double it and move 3 1/4 the ratio, and you know, something like that. And so that this moves at the same time this moves to create a dynamic effect. Sort of like how we automated everything here, except for it's using algorithms so they always move in a predictable way from one knob, even though you can't see the shape. So you may have to become familiar with that filter envelope, or you could just watch it in a spectrum analyzer or a spectrogram of some kind and sort of guess at what the shape is. And that's that. So that's basic filters. If you have any questions, drop them down in the comments, and have a blessed day. That's when we die. Why do you try to see our deeds? Why do you try to look inside? 'Cause when you look and when you see, you must
BS with Jordan.